Good day, everyone. My name is Junil Janbert Biracho, and we're going to talk about logarithmic functions and its key concepts. So, without further ado, let's start. What are logarithms? Logarithms is the inverse of the exponential function. It answers the question, what exponent do we get when we raise the base to get a certain value? Just like logarithmic with the base of 2, number 8 equals 3, because 2 raised to the power of 3 is equals to 8. Let's proceed to our first concept. Zeros, intercepts, and asymptotes of logarithmic functions. Zero or x-intercept, where the graph touches the x-axis. Y-intercept, where the graph crosses the y-axis, if it exists. Asymptote, a boundary line the graph approaches but never touches. Take note, it is always vertical for logarithms. Now, we have example 1 on the zeros, intercepts, and asymptotes of logarithmic functions. So, find the intercept and zeros of f of x is equal to log 2x plus 3. Step 1. Set y is equals to 0. So log 2x plus 3 is equal to 0. Now, the next step is rewrite it in exponential form. Now, 2x plus 3 equals 10 over 0. So we rewrote 0 into 10. 10 is then raised to the power of 0. So in this step, we're going to convert, since any number raised to the power of 0 is equal to 1. So we're going to substitute 10 and convert it into 1. So 2x plus 3 equals 1. Now our step 3, which is the final step, is solve for the x. So 2x plus 3 equals 1. Now transpose 3 to the other side. Get 1 minus 3. Now combine 1 and negative 3. So positive 1 minus 3 is equal to negative 2. Now divide. We get our final answer, x equals negative 1. You can also write it this way. This is our x-intercept. We have here example 2. Find the intercept and zeros of f of x equals log parenthesis x raised to the power of 2. So step 1, set y is equal to 0. Step 2, rewrite it in exponential form. So as you recall from example 1, 0 becomes 10 raised to the power of 0, which then becomes to 1 because any number raised to the power of 0 equates to 1. So we write it like this. X squared equals 10 raised to the power of 0 will then become x squared equals 1. Now our final step, solve for the x. So in order to solve this, we have to get rid of the squared. So we write a square root here and a square there. So cancel. Now, cancel raised to the power of 2. Then x is equal to plus minus 1. So this will be our x-intercepts, 1, positive 1, and negative 1. So step 1, inside the logarithmic, it must be greater than 0. So step 2, we solve for the x. 3x equals 2. Now, just divide it immediately and that will lead you the final answer. So cancel 3, then divide by 3, x equals 2 over 3. And this is your vertical asymptote. We have here example 4. Find the intercept and zeros of f of x equals log parenthesis x minus 4. So if you can recall from the first example, set our step 1 will be set y equals 0. Now, step 2, rewrite in exponential form. If you recall, 0 becomes 10 raised to the power of 0, which becomes 1. X minus 4 equals 10. Then x minus 4 equals 1. Next, step 3, which is our final step, solve for the x. So x minus 4 equals 1. Then you can transpose and combine 4 and 1. You get x equals 5. Period. So this will be your x-intercept. Our fifth and final example. So find the intercept and zeros of f of x equals log 5 minus x. So step 1, set y is equal to 0. Step 2, rewrite it in exponential form. If you can recall what we did in the previous examples, then this would probably be just easy for you. So 5 minus x equals 10 raised to the power of 0. So 5 minus x, now note, any number raised to the power of 0 is equal to 1. So 5 minus x equals 1. Transpose and combine, you get x equals 4, which is our x-intercept. You could also write it in this way, 4 or 0. Let's proceed to the laws of logarithms. In this concept, we're going to focus on its three laws, the power, quotient, and product rule. So in here, you write log, parentheses 2 plus log, parentheses 7. Now in here, you're just gonna multiply the two numbers inside the parentheses. So you're here log, and also since they have the same base, 2 times 7 is equals to log of 14. Now, if you got confused here, let's just say na adding logarithms with the same base means multiplying the arguments. So we have here example 2, subtraction of logarithms, also known as the quotient rule. So log or 50 minus log 5. So since you have the same base, and take note in the quotient rule, we divide the two numbers inside the parentheses. So log 50 divided by 5 equals 10. Now, this is our final answer. And to expound it further, subtracting logarithms with the same base means dividing the argument. So if you can see they have the same base, just divide the two numbers inside the parentheses and you get your final answer. Now we have here our third example under the laws of logarithms, which is about the powers inside the logarithm or the power rule. So our equation log 3 raised to the power of 4, which then equates to 4 times log over 3. Now, if some of you, I know some of you might be surprised on how come this is our final answer. Just remember under this rule, the exponent inside the logarithm will be written as a multiplier in the front. As you can see, our exponent is 4, which is why it's written as a multiplier in front of log 3. Let's proceed to our fourth example, exponent and logarithm relationship. In here, our equation will be log base 2 of 8, which equates to 3 because 2 raised to the power of 3 is equal to 8, or 2 times 2 times 2 is equal to 8. Now, in this rule, a logarithm is the exponent needed to raise the base to get the number. So, our answer here is 3. 3 is our answer here because to get 8, you have to multiply 2 by itself 3 times. So 2 times 2 times 2, 8, 8. So there's 1, 2, 3, 3 twos to get 8. Final example under the laws of logarithms, which is about combining addition and Let's proceed to the final example on the laws of logarithms, where we'll be combining addition, subtraction, and the power rule. So we have log the base 5 plus 2 log 4 minus log 2. Now let's focus on the second equation. So you can notice there's 2 before the logarithm. So what we do to it? We use it to as the exponent of 4. So log 5 plus logarithmic 4 raised to the power of 2 minus log 2. Now I want you again to focus on the second equation. Now what's 4 times 4? So 4 times 4 is equals to 16 since we raise it to the power of 2. So we write log 5 plus 16 minus log 2. Now we combine 5 and 16. So you multiply this since it we this is where we apply the product rule since we can see a plus sign. So 5 times 16 is equal to 85. So you write it this way, minus log 2. I'm sorry, 80 I mean. Log 2. Now here, since you see a negative sign, you'll apply the quotient rule here, in which you'll divide. So 80 divided by 2 is equal to 40. So this will be your final answer, 40. Now let's proceed to our next concept, evaluating logarithms. Evaluating logarithms means finding the exponent a base in which it is raised to in order to get a given number. 2 with 8. So recall that log base of 2 means 2 raised to what power equals 8. So how many times do we have to multiply 2 to get 8? So 2 times 2 is equal to 4, right? 2 times 2 times 2 is equal to 8. So this, how many times should we multiply it? 1, 2, 3. So our answer would be log 2, 8, which equals to 3. For our second example, evaluate log to the base of 5 parentheses 25. Step 1. Identify 5 raised to what power equals 25. So 5 times 5 equals 25. So how many times should we multiply 5? So 1, 2, so 2. So 5 raised to the power of 2 equals 25. Sorry about that. So this will be our final answer. Log 5 with a base of 5 parentheses 25 equals to 2. We have here example 3. Evaluate log with a base of 7 parentheses 49. Step 1. 7 is raised to what power equals 49? So how many times do we have to multiply 7 to get 49? So let's try. 7 times 7, 49. So how many times should we multiply that? 1, 2. So 2 times. So our final answer will be log with a base of 7, 49 equals 2. Since we only had to repeat 7 2 times to get 49. There. Our fourth example, log 12 over 144. Now, what number of 12 is raised to the power which equates to 144? So, let's try 12 times 12. So, so 144. How many times was it? Was it multiplied 2. So our final answer will be log to the base of 12 parentheses 144 equals how many times does it need to be multiplied in order to get 144, which is equal to 2. So this is our final answer. Now our final example here in the under the concept of evaluating logarithmic functions, we have logarithmic to the base of 3 into 81. So 3 is raised to what power equals 81? 3 times 3, 9. 3 times 3 times 3, 27. 3 times 3 times 3 times 3 is equal to 81. So how many times? 1, 2, 3, 4. So 4. So our final answer will be logarithmic with the base of 3 parentheses 81 equals 4. To wrap up the concepts we covered under the logarithmic functions, we focused on the zeros, x and y intercept, asymptote, laws of logarithms, and evaluating logarithms. You can check the references shown below for further knowledge and understanding of the lesson. Thank you all for listening. Goodbye and have a great day.